Hi, hello, welcome back to another function. This is Krish Bavana. I hope you all are doing well and having a great day so far. So, I've tried a new segment in my YouTube channel. It's basically like a mock interview. This is my first time doing them, so they're a bit not really good. But yes, I've tried my level best to make sure you guys to get that interview experience. Just let me know how the interview is, just let me know your thoughts on it, and I'd be waiting for your review. Just let me know how it is in the comments. If it gets 150 likes, I will make another mock interview video which you all might enjoy. This is very simple one. We started to go off slowly. Maybe every week we'll increase the complexity of problems. So let me know how the video is. I'll see you all very soon.
Good afternoon, Krish.
Good afternoon, Soham. How are you?
Pretty good. How about you?
I'm good. Thank you so much.
Yeah, you're ready for this interview?
Yes, I guess I'm ready for the interview.
All right. Whenever you're ready, can you open up Krish mock interview number 2?
Sure, I can do it.
Right now, it's a blank doc, and I will upload the problem.
Perfect.
All right. Do you see it?
It's loading.
It's uploading.
Yep, I see it.
Okay. Okay. So in this example, we are dealing with palindromes. So just a refresher on what a palindrome is. It's if you read a string from left to right and from right to left, they'll both equal the same thing. So
yes,
we're working with linked lists and palindromes. So if you see the input 1 and 2, it's not a palindrome because you read it 1 to 2, and if you read from the tail to the head, it'll be 2 to 1. If you look at example 2, 1, 2, 2, 1 from head to tail, and if you read from tail to head, it's 1, 2, 2, 1. So you output true.
Okay.
We recommend that you make a class for your node for the linked list. You don't have to ask for any user input. All you have to do is just make that class and make a function to determine whether or not a palindrome exists in that linked list. And to do that, we recommend that you use a stack.
Okay, so you recommend me using a stack, and then okay, got it.
Yep.
Perfect.
Do you have any questions?
Nothing right now. I'll start writing the code and just let me know how it goes. And thank you for a good intro. So let's get started. So as you told me, I'll just include some of the basic ones. Let's go ahead on the stream. And I'll be writing this in C++, just a heads up. I guess we discussed this previously. Okay, so firstly we need class. Let me call it node, and once we are here we can start with private, and we should have, for sure we need a data point, so let's have one single data point, and then we are going to have we'll be having a pointer, so it's going to be node next, and that's it in our private because we don't need anything else. And public, I guess you guys didn't ask me for any specific methods inside the public, right? Just making sure.
Correct.
Okay, perfect. So this is going to be my node class, and let me rewind it once again. I will be having private data members. One is going to be int data, which is going to hold all the data which is supposed to be in the linked list, and then the node is going to be a pointer which points to the next node in the entire linked list. Okay, so now let's write our first function, which is not related to the class. We'll be writing and so in the palindrome, what we're going to do is, firstly, we need to create a node, and then we can call it list. I've created an instance for the node, and then instance for the node. And now let's come down here. Okay, so now all I have to make sure is I have to read through I have to iterate through the list, and I have to add every single I have to iterate through the entire linked list, and then I have to add every single element into the stack. Am I right?
Correct.
Yes.
Okay, that's good. So let's say while list dot list points to next is not equals to null ptr. So while the next one in the list is not null ptr, let me also do one more thing. Let me just go and create a stack called S1, and let me create another stack called S2.
Quick question is, I see that you put int data and your node next pointer in private.
Yep.
What would be better to consider is you putting it in public so you could access it later on, because otherwise, my question would be, how would you be able to access?
I can write in getter which returns the int. So I can probably say return data over here, and I can do the same thing for the next also, where I can say it is supposed to be a node pointer though this time, because we're returning a node pointer. I can say get next, and when I'm doing get next, I'll be going with return, and I'll be returning the next. Okay. Got it. So now I'll be having a node list. So the list is going to get its get next. So it should be list next. While lists get next is not pointer, or I can, instead of saying get next over here, I can just say while list is not equals to next pointer, because even list is going to be something, but instead of list, let me go with head, because head makes more sense. And but not head. Let's just with the list, and here we have we will be starting with the head. So can I just draw some diagrams for reference for myself?
Yeah, go for it.
Yeah, please do.
So let's see. So here we're having a head. So let's call this. Sorry, my thing is kind of. And here we have one more. And here we have one more. And here we have one more. Okay. So let's see. We have, this is how a list is. So here we have. So this is our head. Okay. Thank you so much. Let's go to 1. Okay. A node, and then we have I've created an instance for it. So let's see. Now all I need to do is s1 dot push, and now I'll be pushing in the data, and here I'll be telling in list is equals to this next. So now have iterated through the entire linked list over here. And after iterating through the entire linked list, I have pushed every single element, every single data point which is in the linked list into the stack. Let's go and let's make another drawing once again, just to be clear. So I think I drew bigger box over here. 1, 2, 2, and then I have one over here. And this is going to be my top. And the minute if I pop it off from here,
Can you explain the drawing that you have? What looks like to be a stack drawing. Can you just explain what you're
Yep.
thinking is?
okay, sure. So right now what I have done so far is I've created an iterator which iterates through the list and then which pushes in every single element that it has been reading. So I'm just thinking it from the true perspective right now. Okay, got it. Thank you so much. I think that really helped me. So for example, so right now what we have is the top value on the stack is basically the last value in the linked list. And exactly to have, so we can start with the starting node again and we can iterate through the entire linked list and we can check if it actually matches. If it matches, we can pop it off. If it doesn't match, that means there is nowhere the stack is going to get, the stack is ever going to get empty.
Yeah, sounds good.
Yeah,
Okay,
you're on the right
perfect.
track.
Perfect. So let's actually create another node and let's call it list to this time. And let's start iterating through the list. And let's say while list is not equals to, sorry, not list, list 2. While list 2 is not equals to null pointer. So right now the list 2 is actually pointing to the head. We can check if the data in list 2's data, if the list 2 data is equal to s1 dot top, we can actually pop it off. And we can move to list 2 is equals to next. Okay. So right now, if you can have list is equals to list, just next. So we are iterating and we can, we are basically telling it to, sorry, my bad, there's been a lot of extra space which have been created. Okay. So the second while loop is also closed now. So if you think over here, we are iterating, we're telling if the data on the if the data which we're iterating matches the top, then we're telling it to pop it off and we're just iterating. And once the loop has actually ended, if s1 dot size is equals to 0, we can return true. False. Okay. So once the iteration is over, if it actually matches in the exact way the linked list is with the stack, then there's going to be nothing inside the stack because we'll be removing every single element. Then we can probably say return true because that means it is a palindrome. If not, we'll be saying it is not a palindrome.
Okay.
So, yep, that's my explanation. So, do you have anything?
Perfect. So
That was pretty good.
yeah,
Okay.
quick question. So earlier on, we suggested you could also, instead of using a stack, use a queue or a deck, for example. I noticed that you decided to stick with a stack. Any
Yes.
specific reason for this, or what may be the benefits of stacks that you decided to use stacks rather than another data structure or abstraction?
Yes, so the main reason was Stack was following the idea of last in, first out. So which means I know like the last element which is on the stack is going to get off first. So it is easier for me to like pop it off every single time I was iterating through the linked list rather than having a queue, or I could have gone for a double-ended deck or double-ended queue or a deck, which would be easier too, but it is always simpler to go with an easier abstraction when you're solving a problem. So that's the main reason I was still sticking on to the stack. We could have gone with deck, but there was no other way to go with the queue because queue is going to be the first in, first out. And especially the linked list being a single linked list, there's no way that I could point back. So I could never start at the back and then check with it. So that's the reason I thought of going with an stack, sticking onto the stack. That was my reasoning for sticking onto the stack.
Okay, perfect.
What is the big? So you're traversing a linked list and at the same time popping off your stack, correct?
Yep, exactly.
What would you say the big O of those operations are?
So right now the big O of the operations are the entire while loop is going to be an O of n because I am iterating through every single element. And then the pop is going to be just O of 1 because I'm just removing whatever is on the top and accessing every single element in the linked list is going to be O of 1. But the only thing is we are iterating through every single element, which is going to be O of n. Yeah.
All right, that's interesting. So another question is, what's another way that you could have written this code? Maybe like, what's another implementation you could have used instead of using lists and stacks?
Instead of using lists and stacks, I mean, palindrome is a very common program that we could have written in arrays. Maybe we could have had every single element stored in every index of an array, and we could have probably iterated through it and do the same exact process and push it into a stack and then check it off. And this is not a good idea for BSTs, especially when we know BSTs follow the idea of slicing everything in half and checking. So it's really not a perfect data structure to go with the idea of palindrome. So I think I would either go into an array or stay with linked list. But my only favorite thing about linked list is if I have to add anything in middle or if I have to add anything somewhere with no specific position, it's always easier for me because I just have to create a new node and I can just point it off. I can point off the new node to the next one and the previous one to the new pointer. So that's the reason I would still stick with the linked list.
Nice. Okay.
Could you scroll up to the class up just for a couple seconds?
Yep, sure.
All right, I believe that's all the questions I have. Did you have any other questions, Hari?
Just one last question. So I noticed in bool is palindrome.
Yes.
There seems to be no parameters. If you were to add one, or if you chose not to add one, what would be your reasoning?
There's specifically nothing that we have been going with here, but for example, if we have like another method which holds in a stack, which is previously done for us, or maybe if we have like, for example, some people like really like to create all those in the main and pass it in as a reference.
Mhm.
So maybe that could be another way. Maybe if we have like a main, we could probably have a special stack and a list ready for us, and then probably we can bring it in into the palindrome, which is much easier. So yeah. Other
Okay.
than that, there's no actual reason to have any other parameters for this specific problem.
All right.
Okay, I do have one last question before we head off.
Perfect.
What would you say is a good way you can optimize your code for future times if you were to rewrite this code at a later date?
Yes, for sure, I would reorganize my function a bit more clearly, because when I was writing in the fast-paced mode, I was not really going through it exactly, because for a few parts, like instead of just pointing to next, I should actually point to get next method. So these are a few things which I would for sure make sure to write it clearly when I'm writing it next time. And other than that, I would still stick on to going with a stack, because stack seems much easier other than queue or deck. So I would probably still stick with the idea of stack.
Alrighty, thank you for your time, Krish. We will get back to you
Thank you.
soonly. Good job.
Thank you so much, Soham, and thank you so much, Harry. Thank you so much for giving your time. See you.
Thank you. Have a
Bye
great
bye.
day.
Thanks, Ethan.
Yeah.
So that's the video for today. I hope you really liked it. Let me know how the video is. Please let me know in the comments. This is something, I know these are lengthy, I know these are long, but if you guys like it, I'll make another one. 150 likes for another mock interview. So I'll for sure not upload them during like on Wednesdays. I'll probably upload them on Saturdays, just so that people who are just loving my Wednesdays content will still stick on to those Wednesday content. But for anybody who's interested in mock interviews, I'll put them on Saturdays or Sundays depending on when I do them. So yep, that's the story. I'll see you all very soon again. Until then, signing off. This is Krish Bavana.